Before delving into the details of the declaration, it is crucial to first understand the magnitude of what is at stake. The Large Hadron Collider, LHC, operated by CERN, represents an extraordinary milestone in the realm of scientific advancement. Spanning a vast 17 miles, this cutting-edge system of superconducting magnets stands as the most powerful particle accelerator ever constructed. It serves not only as a remarkable testament to human innovation, but also as a symbol of the remarkable progress we've made in our understanding of science. The LHC has the astonishing ability to replicate the conditions that were present at the birth of the universe itself. However, as we embark on exploring the vast unknowns of the cosmos, a vital question comes to the forefront. Could this advanced machine, designed to uncover the deepest secrets of the universe, also introduce unforeseen risks? CERN, founded in 1954, is one of the most renowned scientific organizations in the world, with 23 member nations and an extensive research community. It serves as a hub for collaborative research and pioneering discoveries. While the LHC is undoubtedly its flagship project, it is only one component of a much larger network of particle accelerators and experiments. Rather than thinking of it as a racetrack for vehicles or animals, consider it more akin to a high-stakes race for subatomic particles. These particles engage in a race that tests the limits of speed, precision, and even the very nature of space and time itself. Inside the LHC, protons are accelerated to speeds that approach the speed of light, mimicking the energy levels present at the instant of the Big Bang. The resulting collisions generate temperatures far higher than those at the sun's core. A series of magnets steers the protons along their designated paths, while advanced cooling systems ensure that the magnets remain at temperatures colder than those found in outer space. These collisions are deliberately staged at 4 distinct locations within the accelerator, where specialized detectors ATLAS, CMS, ALICE, and LHCb capture data. Each of these detectors has a unique function, offering different perspectives on the aftermath of these intense high-energy impacts. Together, they act as colossal cameras, recording the consequences of these collisions, with scientists carefully analyzing the remnants to identify elusive particles like the Higgs boson, often referred to as the God particle, along with other phenomena that might shed light on the fundamental elements of the universe. By zooming in on subatomic particles, researchers aim to gain a better understanding of the very structure of our cosmos. Still, every new revelation at the LHC only seems to raise more questions. The LHC is not merely a machine. It is an embodiment of humanity's unyielding curiosity and our relentless quest for knowledge. It represents our desire to understand the forces that shape our very existence. Yet, as we push the boundaries of the unknown, we must confront the moral and existential dilemmas that accompany this exploration. What dangers could arise from probing the unknown? Could our insatiable search for knowledge open doors to forces beyond our control? At CERN, where the limits of human understanding are being tested to their fullest, a disturbing realization has surfaced, one that has shaken even the most experienced scientists. Brian Cox, a former CERN researcher and a respected figure in particle physics, recently made a statement that has intrigued and alarmed people worldwide. Cox disclosed that the purpose of the LHC is to simulate a miniature version of the Big Bang. Essentially, a mini Big Bang. He elaborated on the immense potential of the LHC to make groundbreaking discoveries, such as unveiling the mysteries of dark matter, a substance that makes up much of the universe. The idea of harnessing the fundamental forces of the universe is undeniably exciting, but it also comes with considerable risks. The mini Big Bang is not just a theoretical construct. It is an actual phenomenon that occurs within the LHC. The collider recreates extreme conditions of heat, pressure, and energy that mirror those present at the universe's birth. It's as though we're witnessing the birth of time itself. However, with such colossal power comes a tremendous responsibility. What if something goes wrong? This concern is not new. Back in 1978, Russian physicist Anatoly Borsky had an experience that forever changed his life. While working with the U-70 synchrotron at the Institute for High-Energy Physics in Ingrad, Russia, a malfunction caused a proton beam to accidentally cross his path. Traveling at unimaginable speeds, the beam penetrated his skull, entering from the back and exiting through his nose. Despite being struck by a flash of light brighter than 1,000 suns, Borsky remained conscious and walked to seek medical attention. The aftermath was both astounding and terrifying. He lost hearing in one ear and experienced partial facial paralysis. Despite the severity of his injury, his cognitive functions remained intact, and he continued his scientific endeavors. Borsky's experience serves as a grim reminder of the immense power and potential hazards associated with particle accelerators. The dangers of devices like the LHC should never be underestimated. Some scientists have expressed concerns about the possibility of unexpected reactions that could alter the very fabric of reality. For instance, there are fears that the LHC could potentially create a miniature black hole. Black holes are regions of space where gravity is so intense that not even light can escape. These destructive forces exist at the edges of the cosmos, and the thought that the LHC might create even a small black hole is both awe-inspiring and terrifying. Could such a black hole grow uncontrollably, eventually consuming the Earth from within? Researchers at CERN have attempted to reassure the public, asserting that any black hole created within the collider would be highly unstable and would disappear almost instantly. Still, the very possibility of such an event has sparked widespread debate and concern. To understand how the LHC might create a black hole, one must first grasp the fundamental mechanics of a particle accelerator. When protons collide at near-light speeds, the energy released is so immense that it can distort the very fabric of space and time itself. To visualize this, imagine a trampoline stretched tightly. If a heavy object is dropped onto it, the fabric bends. If the object is large enough, it can create a deep depression, pulling anything nearby into it. This analogy helps illustrate how the LHC could influence spacetime at the quantum level, where the laws of physics become unpredictable. One theory suggests that extra dimensions beyond the familiar 3 of space and 1 of time might exist. If such extra dimensions do exist, the LHC might have the ability to access them, potentially creating a gravitational well that could lead to a tiny black hole. This theory has attracted the attention of renowned physicists, including the late Stephen Hawking. In his writings, Hawking warned that the Higgs boson could become unstable at extreme energy levels, possibly triggering catastrophic events like vacuum decay. Sir Martin Rees, a distinguished astrophysicist, also raised alarms in his book on humanity's future. While acknowledging that the likelihood of such an event was low, he emphasized that even a small chance warranted serious attention. The stakes are incredibly high, and the margin for error is razor-thin. CERN researchers have conducted numerous simulations and analyses, taking every possible precaution to ensure the safety of their experiments. Brian Cox himself has addressed the concerns surrounding the LHC, emphasizing that stringent safety protocols are in place. These measures include thorough reviews to ensure that the collider's operations are carried out with the utmost caution. According to Cox, the energy levels involved in LHC experiments are much lower than those that naturally occur on Earth. Even if a black hole were to form, it would be so small and unstable that it would dissipate quickly, releasing energy in a burst, as predicted by Hawking's theory of Hawking radiation. Some have speculated that the LHC's experiments could open a portal to another universe or dimension. While most mainstream scientists dismiss this idea, it has captured the public's imagination, fueling myths and rumors. What lies beyond our universe? Could we unknowingly release forces or entities that we are not equipped to understand? The concept of parallel dimensions is not a new one. String theory, a leading candidate for a unified theory of everything, proposes the existence of more than just the 4 dimensions we experience, 3 of space and 1 of time. These additional dimensions may be hidden from our senses, but under extreme conditions, they could potentially be accessed. Imagine the LHC as a key that unlocks doors to realms that have remained hidden since time began. When protons collide with energies never before witnessed on Earth, they could create ripples that probe these unseen dimensions. While this remains speculative, it illustrates the allure of the unknown. The possibility of discovering other dimensions continues to captivate the public, even though most scientists remain skeptical that the LHC will open a portal to another universe or unleash something far more terrifying. Should we be concerned about the risks associated with the LHC? It is easy to become caught up in sensational headlines and fears of cosmic catastrophes. However, The reality is that scientists at CERN are well aware of the potential dangers and have taken extensive measures to ensure the safety of their experiments. They continuously monitor and assess their work with the highest level of diligence. The potential rewards of their research, such as unraveling the secrets of dark matter, discovering new particles, and deepening our understanding of the universe, are truly remarkable. These breakthroughs represent a giant leap forward in human knowledge, but they do come with inherent risks. As with any groundbreaking scientific endeavor, the experiments conducted at the LHC raise profound ethical questions. Could the creation of exotic particles or the exploration of extreme energy conditions lead to unforeseen consequences for our planet or even the very fabric of reality itself? These questions must be addressed carefully, considering the broader implications of scientific progress. In conclusion, the Large Hadron Collider is a monumental achievement in human ingenuity and curiosity. It has already led to groundbreaking discoveries in particle physics, shedding light on the fundamental workings of the universe. Yet, as we continue to explore these uncharted territories, we must remain vigilant and mindful of the potential risks involved. The pursuit of knowledge is one of humanity's most ambitious endeavors, but it is not without its challenges. The LHC stands at the forefront of scientific exploration, where theory intersects with experimentation, and where the foundations of our understanding of the universe are being tested. The journey of discovery is never without peril, and the LHC is no exception. It pushes the boundaries of physics, seeking to reconcile the fundamental forces of nature and answer age-old questions about the origins of mass and the nature of dark matter. However, as we delve further into these frontiers, we must remain cognizant of the profound ethical and existential dilemmas that arise from manipulating the forces that govern the universe. The risks of unintended consequences, whether for our planet or for the very fabric of space-time, remain challenges that demand thoughtful consideration. Nonetheless, the pursuit of knowledge remains one of humanity's most noble undertakings. The LHC's experiments, while risky, offer us a glimpse into vast, unexplored realms of science. As we stand on the brink of discovery, we must approach this journey with both ambition and caution. The LHC represents not only the pinnacle of human technological achievement but also a powerful tool that could reshape our understanding of everything, from subatomic particles to the grandest cosmic phenomena. With each breakthrough, new questions arise, opening fresh avenues for exploration and thought. The path of scientific discovery may be uncertain, but it holds the promise of revelations that could redefine our understanding of the universe, our place within it, and the very laws that govern reality. One of the most profound aspects of the LHC's experiments is the intersection of theory and reality. For decades, physicists have wrestled with understanding the forces that govern the cosmos: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. The ultimate goal has always been to unify these forces into a single, cohesive framework, a theory of everything. The LHC has played a pivotal role in providing experimental evidence and insights that bring us closer to this elusive goal. Its work not only enhances our understanding of particle physics, but also holds the key to uncovering the fundamental truths of existence itself. The ethical dilemmas tied to these experiments are significant, but the pursuit of knowledge has always involved risks. However, when those risks involve altering the very fabric of space and time, the stakes become immeasurably higher. Could a single experiment at the LHC inadvertently trigger an event that we do not fully comprehend, leading to consequences beyond our ability to predict? This is a question that scientists, philosophers, and ethicists continue to explore. As we journey into these uncharted realms, we must remember the immense responsibility that comes with wielding such vast power. Despite the potential dangers, few would argue against the pursuit of scientific progress. The rewards, new technologies, medical advancements, and a deeper understanding of the universe are immense. The discoveries made by the LHC so far have already transformed the scientific landscape, from the identification of the Higgs boson to advances in our understanding of dark matter. These achievements have far-reaching implications, not just for physics, but for other fields that rely on this foundational knowledge. As we continue to push the boundaries of what is possible, The LHC serves as a reminder that science is never without uncertainty. No experiment is entirely risk-free, and the LHC, as grand and powerful as it is no exception. But with every risk comes the potential for monumental discoveries. The LHC symbolizes humanity's relentless pursuit of knowledge, a quest to answer the questions that have puzzled us for centuries. Ultimately, it is this curiosity that propels us forward, the desire to understand the universe, to peer into the depths of space and time, and to uncover the forces that govern everything from the tiniest particles to the largest galaxies. The LHC may carry risks, but it also represents the zenith of human achievement in particle physics. It is a tool that allows us to explore the most profound questions about existence, challenge the laws of nature, and seek answers to the mysteries that have eluded us for millennia. Whether or not the LHC will lead to the discovery of new dimensions, open portals to parallel universes, or trigger unforeseen phenomena remains uncertain. What is certain, however, is that it is one of the most powerful instruments ever created, capable of unlocking secrets about the universe that were once thought beyond our reach. The potential for discovery is boundless. As we venture further into the unknown, we are reminded that science is a journey, one that requires both boldness and responsibility. The experiments at CERN continue, and we must remain alert to the possibilities, the risks, and the immense potential for new understanding that lies ahead. The LHC, while embodying the cutting edge of modern science, also reflects our deeper quest for meaning and understanding in a vast and mysterious universe. Each new discovery brings us closer to a fuller comprehension of the forces that shape our existence.